One, two, three. Action!
Binary tree. What is a binary tree? It is a hierarchical data structure consisting of nodes and edges. The first node is the root node. Hello. The root node in this case serves as the entry point to the tree. He does not have any parents. This root node is now the parent node for these two children. He is the left child of this parent and he is the right child of this parent. Let's move forward. He is the child of the main root node, but he also has more children. Here is the left child of this child. Now in this case, for him, he is the parent and he is the child of Santosh. Here, Sharan is the right child of Nikhil. Nikhil is the parent of Sharan. Now unfortunately, these two children do not have any further children and they are called the leaf nodes. Now what is the use of a binary tree? It is used for efficient searching and construction of trees. Do you want to learn more? Let's go on. This is a tree that we had showed you earlier. Let us organize this tree a bit by distributing their index numbers. The root node has the index value of 0. The children of the root node have index values 1 and 2. The children of the left child and the right child have indexes 3, 4, 5 and 6. Now as we can see, all these three people are sitting in different levels. This is the concept of levels in a binary tree. On the first level is the root node. Second level, there are two nodes which is the children of the root node. On the third level, we have the children of each of the children of the root. And these are the leaf nodes.
Let's start with traversal.
Let's start with traversal. What is a traversal? Traversal is the process of visiting each node in the binary tree. Let's start with the root.
I am the root node of this binary tree and I have two child nodes, left node and right node. As we are going with in-order traversing, we will move with left node.
I am the left child node of parent node. I already have two leaf nodes as a child node 3 and 4.
I am the leaf node of parent node 1. I don't have any leaf nodes, so I will go.
I am the left child node. I don't have any child nodes.
I am the right leaf node. I am the son of child node, first child node.
As the in-order traversing, I am the root node, so I will move.
I am the child node of the root node, and I could have the two child nodes, that is 5 and 6. I am the left child of the root node 2, and I don't have any child nodes, so I am going first. I am the parent node of the two child leaf nodes, and now I will go. I am the last node here, so I will go.
This is the in-order traversal of the binary tree. Let's go with the next type of traversal, which is pre-order traversal.
With the index value 0. As we are going with pre-order traversing, the root come first, so I will move first.
Child of index 0 and move first. 1 second.
I am the left node of index 1. Leaf node of 1. I am the right leaf node of 1. I am the child node of the parent node, and now I will. I am the left child of the root node 2, so I am going to leave. And the last node, so I will.
This is the pre-order traversal of the tree. Let's start with the next type of traversal, which is post-order traversal. This traversal follows the format of left, right, and then the root node. Let's start with the root node.
And the root node of index 0, as we are working with the post-order traversal, which moves right.
And the left child of the parent node has an index 0. I have a two children.
I am the leaf node of the parent node, number 1 index. I don't have any leaf nodes. Now I can go. I am the right leaf node of 1, so I don't have any child. I can leave.
I am the left child of the parent node index 0. Don't have any children node. I will.
So next, I am the left child of the root node 2. So I don't have any children nodes. So I am going to live in order post order traversal.
I am the right child of index 2. I am the right child of parent node. And post order traversing. Now I can do.
As the method of post-order traversing, all the nodes have been arranged. So the last node is 0, so I am dead.
This is the post-order traversal of the tree. Let us start with the next concept, which is binary search tree. This concept is used for searching nodes within certain data, and the tree is arranged in such a way that the left child of the parent node will always be lesser than the parent node, and the right child will always be larger than the parent node. This reduces the search time to O of log n complexity. Let us start with the demo. Now we have a set of nodes which we will arrange in a binary search tree format. Let's start with the first node, which is node 3. The first node is always the root node of the binary search tree. The next node is number 5. Please come. Number 5 is greater than 3 and thus will be the right child of 3. Next is number 1. Number 1 is lesser than root node, which is number 3, and thus will be to the left side of the root node. Next is number 4. 4 is greater than 3 but is lesser than 5, and thus will sit to the left side of 5. Next is 6. 6 is greater than 3 and is greater than 5, and thus will sit to the right side of the child node of 5. Next we have 0. 0 is lesser than 3 and lesser than 1, and thus will be seated to the left child of the node 1. Finally, we have node number 2. 2 is lesser than 3 but is greater than 1, and thus will sit as the right child of the parent node 1. This is the binary search tree. Let us demonstrate the searching algorithm. Let us say we want to search for the number 4. We will start with the root node, which is 3. Now we know that 4 is greater than 3, and we will search the right subtree. Let us demonstrate the binary searching algorithm. Let us assume that we want to search the node number 4. We'll start with the root node. In this case, the root node is 3. Now we know that the number that we want is more than 3. So all we have to do is search the right subtree. So we can do away with the left subtree. Now let us search only the right subtree. Now we know that the root node is 5. The number that we want is lesser than 5, and thus we have to search only the left subtree of the root node 5. We can do away with the right subtree. We have only one node left, and in this case it is number 4, and thus we have found the search is successful. Let us search for another number. Let's say we want to search for the number 10. We will again start from the root node. The root node is 3. We want to search for 10. Thus, we have to search for the right subtree. We can do away with the left subtree. Now, let us check the right subtree. The root node of the right subtree is 5. The number that we want is 10. We have to search the right subtree of 5. We can stop searching the left subtree. We have only one child node left, and that is number 6. It is not equal to 10. Thus, we do not need 6. Unfortunately, there are no other nodes left, and thus the search is unsuccessful. We can report that 10 is not there in the tree.
Let's break the tree.